Right, we'll look at some trig identities. So there's two trig identities that you need to learn. Okay, so you need to learn that sine squared x plus cos squared x is equal to 1. That's the first one. Now the second one is you've got to learn that tan x is sine x over cos x. Now, what's really helpful is there are two different ones that can be adapted from that one, and if you learn them just now, it saves you worrying about it if you're in the middle of doing a question. So what you can do is you can rearrange that to leave cos squared x. So if I rearrange that, just think of changing the subject of the formula. Cos squared x is equal to 1. I take sine squared x off that side. I've got to take it away from this side. So that means that cos squared x is equal to 1 minus sine squared x. So sometimes you'll see that. Once you get to recognise it, you know to replace it with cos squared. Now, likewise, I can change the subject of the formula of this one so that I've got sine squared x equal to something. So sine squared x is going to be equal to 1. Take away cos squared x from both sides. So sine squared x is equal to 1 minus cos squared x. Now, those are the two formulae that come from this. So try and remember them. You don't need to remember them, you can work them out. Okay, this is the one that you really need to know, and from that one you can adapt to work out the other two. Okay, now the other thing that you've got to know is that tan squared x is exactly the same as sine squared x. Tan squared x is equal to sine squared x over cos squared x. So you're squaring that here. So you square that one and that one. So make sure you know that as well. Now there is another one where tan x is basically put in the denominator. Now we know that every number we can write is over 1, but we don't write over 1. But if we are changing tan x to 1 over tan x, what have I done? I've turned that upside down. So turn this thing upside down. So 1 over tan x is cos x over sine x. Now a wee way to remember this is the sine bit goes at the top, goes with the tan. So if tan is at the bottom, it starts with sine x, and then cos x goes to the opposite side. So those are two other formulae that you really have to be able to use. Right, we'll try a couple of questions. Okay, so we'll try this one. It says tan squared x times cos squared x, and we've got to simplify it. So on that page a minute ago, I've worked out that tan squared x was sine squared x over cos squared x. So all I've done is I've replaced the tan squared. Okay, so I've replaced that with that. Okay, all on the previous page. Now, I've got to multiply that with cos squared x, but we've got to simplify. So when I look at that, I can see that there's a cos squared x in the numerator, there's one in the denominator, they cancel each other out, and when I do that, I end up with just sine squared x. Another one, I've got to prove, so the last one there was just simplify, so it's not left hand side and right hand side. This one is prove something. So when I'm proving something, I'm starting off with left side equals, and the left side is sine squared x divided by 1 minus sine squared x. Now I'm keeping a wee eye on this. I know that tan squared x is sine squared over cos squared. So I'm looking at this bit here. What's that equal to? If we look at this 1 minus sine squared x, and we go back to the previous one, the identity page, I can see that cos squared x is 1 minus sine squared. So you're looking for this thing here. So there it's there. So 1 minus sine squared is the same as cos squared. So that means that gives me sine squared x at the top. The bottom bit I know is exactly the same as cos squared. So I write that in. Back to that identity page. What is sine squared x over cos squared x? It's tan squared x, and that is equal to the right hand side, and we've proved that identity. Now this one here, don't see anything really that's that relevant. We've got one expression divided by another thing. So this one here, the only thing we can do is actually split it into fractions. So I've got sine x over cos x. And then I've got 2 cos x over cos x. And that's the only thing really I can do with that one. So when I look at that, is there anything that I can use an identity? Can you see any identities there? There's one there. What's sine over cos? Sine over cos is tan, so that becomes tan x. And what's 2 cos x divided by cos x? Cos x, top and bottom, cancel, so that becomes tan x, add on 2. And that's that one done. So that one was a wee bit different from ones that you've done before. This one is an expand, so we don't have a left side and a right side. So we want to square this bracket. So square it the way you've always squared brackets. So sine x plus cos x multiplied by sine x plus cos x. That's same bracket, squared means multiplied by itself. Take the first term in the first bracket and multiply it with the second bracket. So we've got sine x, second bracket is sine x plus cos x. And then we move on to the second term, which is plus cos x, and multiply that by the second bracket, which is sine x plus cos x. Now, once you've done that, we need to expand those brackets. So what is sine x times sine x? That's going to be sine squared x. And then we multiply sine x by cos x. So that gives me sine squared x for the first term. And sine x times cos x is plus sine x cos x. Then we move on to the second bracket, and I've got cos x multiplied by sine x. Now that's the same as sine x times cos x. So I'm writing down sine x times cos x. And I've just swapped them round so it looks like that one. And then the last thing there is I've got cos x times cos x. So when you multiply something by itself, it's squared, so it's cos squared x. Now we've got to tidy this up. So the first thing I can see here is we've got a sine cos and another one. So I've got 2 of them. So I'm going to write that in. So I've got 2 sine x times cos x. There's 2 of them, identical terms. It's like AB plus another AB. So I've got 2AB. Now the next thing I'm looking for is I can see part of an identity there. I can see a sine squared plus a cos squared. And what is a sine squared plus a cos squared? Back to your identity page, it's equal to 1. So it's 1 plus 2 sine x cos x. Okay, the next one, we've got to show that. So we're starting off left side equals. So if it's a prove or a show that, you're starting off with left side and you're proving equal to the right side. So we've got tan x times cos x. Now there's nothing I can do here apart from replace tan x with sine x over cos x. So we do that. So sine x over cos x. And we've got to multiply that by cos x. And then when I look at that, what can I see in the numerator that's the same as the denominator? Cos x. They cancel out. And the answer is equal to sine x. And that's equal to the right side. And that's us proved that one. Okay, next one. Question 6. We want to show that. So we're starting off with left side equals. And the left side is 2 minus 2 sine squared x. If you see something like that, there's a number in common, you always take any number like that out as a common factor. So I'm going to divide it all by 2. So I get 2 times 1 minus sine squared x. Now, what is that equal to? 1 minus sine squared. Back to the formula right at the start that I went over. And I know that cos squared x is 1 minus sine squared x. So there is that 1 minus sine squared. So 1 minus sine squared is the same as cos squared. So that becomes 2 cos squared x. That's the same as the right hand side. So that's me. I've proved that identity. Okay, another show that one. So as soon as I've got to show that one, it's left side equals, and the left side is cos x times sin x, all divided by tan x. Now, tan x is at the bottom. So when tan x, that's like 1 over tan x. We flip the sin x over cos x upside down. So I'm going to write the cos x sin x that's already there. So that's that one that's already there. Now that tan x is down at the bottom, so I'm going to flip that upside down, and when I flip that upside down I get a sin x at the bottom and another cos x at the top. I'll make that just a longer line. Right, can we see anything that cancels top and bottom? Yep, there's a sin x and a sin x, so that goes. And what's cos x times cos x? It's cos squared x. It's exactly the same as the right side, so I've proved my identity. Okay, another one, show that. So we're going to start with left side equals. We've got cos x times sin x times tan x. Now the only thing I can see there from my identity is this tan x, so we're going to replace it. So we'll replace tan x with sin x over cos x. So we've already got cos x times sin x here. And tan x becomes sin x over cos x. What can I see top and bottom that are the same? I can see a cos x. So that cancels out with that. I'm left with sin times sin. Sin times sin is sin squared x. And that's equal to the right side that I was asked to prove it equal to. Now this one's a wee bit different. We've got show that 2 minus 5 cos squared x is equal to this thing. So these numbers are different, so I can't take out a common factor, can't do anything there. So the only thing I want to look at is the fact that the cos squareds have turned into sin squareds. So we think back to our identity. I don't want cos squareds in there. But do I know a replacement for cos squared? I do. There's the replacement there. Cos squared x is equal to 1 minus sin squared x. So instead of saying cos squared x over here, I'm going to change it to sin squared. Now, I've got to show that, so I start off with left side equals, and it's 2 minus 5 cos squared x. I don't want that cos squared x to be there. There are no cos squareds on the other side, and there's nothing really that I can do with that. So the only option that I've got is to replace cos squared x. But I know that cos squared x is 1 minus sin squared. So if I do that, the 2 stays where it is, the 5 stays where it is, but it's now multiplied by 1 minus sin squared x. That's all I can do. But I have to tidy that up. So I've got 2, and I do minus 5 times 1 is minus 5. And minus 5 times minus sin squared is going to be plus 5 sin squared x. Again, we can tidy this up a wee bit. I've got 2 take away 5. So that's going to be minus 3. I've got 5 sin squared x. If I look at the other side, the right hand side, that's the same. It's just written around the other way. So 5 sin squared x minus 3 is equal to the right side, and that's that one replaced. So I knew that I had to replace cos squared with that, because when I looked at that, there was no common factor there, so I couldn't pull out a common factor. So I could never get the same number in front of those two things. So I've changed cos squareds, and I know they had to go to sin squareds, so I changed cos squared into 1 minus sin squared. That one's a bit more tricky. Right, next one. When I'm doing this one, I'm looking at cos cubed x plus cos x times sin squared x, and that's equal to cos x. So as I show that, so we start with left side equals, and the left side is cos cubed x plus cos x times sin squared x. Now, looking at that, we know things about sin squared plus cos squared, but I've got a cos cubed. So the only thing I can do here is take out a common factor, and the common factor there is cos x. So when I take cos x out as a common factor, cos x times what gives me cos cubed? It's cos squared x. And then when I pull out cos x as a common factor from this side, I'm left with sine squared x. Now, what is cos squared plus sine squared, or sine squared plus cos squared? That is one of the identities. So sine squared plus cos squared is equal to 1. So that's equal to cos x multiplied by 1. And I'm showing that I know that that's 1, but that is, of course, it's just cos x. And that's equal to the right-hand side. And that's that identity shown. Similar one, I've got sine cubed x plus sine x times cos squared x is equal to sine x. I've got cubed terms here, don't really want that, but I can see that there's a sine x there and there's a sine x in there. So if I pull it out as a common factor, but I've got to start off with left side equals sine cubed x plus sine x times cos squared x. We'll pull out sine x as a common factor. So when I pull out sine x as a common factor, sine x multiplied by what gives me sine cubed x? It's sine squared x. Pull sine x out as that as a common factor, and I've got cos squared x. What do I know about sine squared plus cos squared? I know it's equal to 1. So that's sine x times 1, and I'm writing it in bracket just to prove that I know that. So that's equal to sine x, and if I look, it's exactly the same as the right side, and I've proved that one. Okay, last one for now. We've got to show that. So I'm starting off with left side equals, and I've got sine x times tan x. Only thing I can do here is replace sine x over cos x for this tan x. So I'll do that. It's the only thing I can do. So leave the sine x there, and that tan x becomes sine x over cos x. I want to tidy that up. Don't really like that. So sine x times sine x is sine squared x. Something multiplied by itself is squared. And we've got a cos x at the bottom. Now, I could finish it there, but if I look up here, I've got the cos x at the bottom, that's okay. But I've not got sine squared x at the top. So I've got to think about what sine squared x is equal. So back to those two adapted identities. I know that sine squared, there it's there, sine squared x is 1 minus cos squared x. So I know I've got to replace that. So it becomes 1 minus cos squared x, and that's all divided by cos squared, or cos x. And that's exactly the same as the right side. So that's the right side. Right, that will do us for now. I will do another wee video on trig identities because there's a lot in them. Okay.